I've got another repair in here. It's a CNC machine. It's for a router, a CNC router, and it's just a control pad, basically. Just a remote control pad. What this is preventative maintenance because of a previous repair that's happened. I'll show you in a minute the prices for all this gear. So on the bottom of these handsets, you've got the cable. One end plugs into the handset itself, and then the other end goes up to the controller for the CNC machine. And when this is plugged into the bottom of the remote, it actually, I mean, this is quite a well-made cable, but it's at the same time it's pretty vulnerable, so I guess you could argue it's not very well made. So I'll show you. So we've got this connector goes in the bottom here, you know, and look at this, and it's, you know, quite rigid, and you're not going to pull that out easily. That's fairly okay. That the trouble is, it's quite a small surface area, but quite a long lever. So if you drop this, then what's happening is it's just snapping off. And this has got quite a bit of heft to it. It's a cast aluminium rear case. You know, there's quite a bit of weight to this. So if you drop it, these just snap clean off. Okay, what I'll do now is I'll show you some slides I've got for replacement controllers, just for the sake of interest, so that you've got a sense of scale, and replacement cable looms. These connectors are not ridiculously easy to get hold of, but I guess you could make something up yourself if you were that way inclined. But a replacement cable for one of these is, well, frightening. I'll show you the prices. So here we've got a remote on one website, 2,640 Australian dollars. Another one here, £2,002 for a remote. 85 US dollars for a replacement cable. And another one, $89. And then a little bit later I found a CNC machine discussion forum where a guy was complaining about a fault with a handset. And a reply was, unfortunately, until multicam start accepting repairs again, your only alternative is to buy a new handset, basically. So, you know, thanks a lot for that. The preventative maintenance that I'm talking about is basically to replace this plug socket arrangement with a simple grommet. Now, the idea is this. We have the cable permanently attached to the handset just with a grommet, and I'm going to stick a load of heat shrink wrap over it to give some strain relief. This is not going to snap. This is pretty hefty. It's not long enough to snap, so if I just remove it, this is the actual part that goes into the handset. So it leaves, when this is cinched down, it leaves only a very small amount, which you can see there's a big difference between this and the plug socket arrangement. This, by the way, is rock solid plastic. So this does not bend in any way whatsoever. So you can see that that gives you far less of a lever. So the next thing after that would be to fit a load of shrink wrap over the outside edge so that it gives some sort of strain relief. The next thing I need to do is get the back of this thing open. Now this is used in quite a dusty environment and there's quite a lot of junk on the outside of it. Somebody's put some kind of a screen protector on the outside. That's not a bad idea for something that costs so much. The trouble is that there's all this white powder underneath. Now if I open this controller up, then there's some risk that some of this junk is going to end up inside underneath the LCD, and it just looks appalling. It's not like that right now. There's no white powder inside it now, and I think it'd be a shame if I do some kind of a repair or maintenance and then when I'm finished there is white powder inside. So the first thing I'm going to do is get all the junk off the outside edge. And here's where we slide into my favourite cleaning products. Glass cleaner. It's fairly mild. I've never had any reaction with any plastic or sort of sign writing on any of these kind of membrane keypads or anything like that. Never had any reactions with any paint. So that stuff works on some kinds of staining and dirt and detritus. Mr. Sheen, just spray polish. I don't know if it's the solvents in it or if it's the slightly greasy nature of it, that it's some kind of oil based. I'm not entirely sure. Mr. Sheen tends to get just about anything off anything, and it doesn't cause any kind of, again, it doesn't lift paint or anything like that, so that's really good. This stuff I have to be careful with. It'll lift things like permanent marker from just about anything. The trouble is that I have had some reactions with plastics, so generally I'll test it on a really small area first just to make sure that it doesn't, you know, do anything silly on me. And then if I get really desperate, good old acetone. This stuff is a plastic killer. It will utterly destroy 99% of most plastics. So this stuff I have to be very careful with. Very aggressive solvent. What I'll generally do is I'll go from the weakest up. So if the weakest stuff takes all the junk off the item, then that's it, that's all you need. If it doesn't work, move on to something a little bit more aggressive and progressively work your way up. What I tend not to do is start with, you know, a 10 megaton nuclear bomb. You know, usually it's better to start with something a little bit less powerful. Right, so first thing first, we'll just get this off here so that I can effectively remove all that junk. That's the window cleaner. And you can see all the junk starting to come off there. Okay, and just to give some more detailed cleaning, I'll just spray some of it on the cloth itself. And that's, you know, really brought that up really clean. So this is where these sorts of multi-bit sets come in quite handy. So they're fairly cheap and nasty. I mean, you can get these from supermarkets and all sorts of stuff, eBay. I've used these outdoors. This thing has been filled with water when it's been raining. Periodically I need to get these things out and wipe them down with a bit of oil, but yeah, they come in quite handy. They're generally made of marzipan, so once you've used them 3 or 4 times they're totally wrecked. Usually it's, you know, you're working on a rusted nut, bolt, fastener or whatever, and it's not going to move, and the amount of force required to make it move is beyond what these are capable of delivering without eating themselves. So periodically I'll buy another set and you know, top the old one up or whatever, and I've got a tub elsewhere with a load of spares. So yeah, these come in quite handy for this sort of stuff. I'm not aware of any like really expensive super fandabidozy tungsten carbide tipped diamond ingrained stuff that's, you know, actually pretty hard, decent stuff. Most of these that I've seen have been cheap, nasty marzipan, you know, fairly soft steel, I guess. So I've got the bits I need sort of already set up. Just got the These are really quite a fine pitch screw. So if you're doing this with a normal sized screwdriver handle, it would take quite a long time to actually remove the screw from the thread. Done this way, it can be fairly quick. Okay, and that's it. Removed. So I just want to be careful here because we've got this cable underneath. Oh, look at that, the way that that was twisted up. You'd expect better than that. That is not very clever. Okay, so the end result of this is going to be that the cable assembly will come up through that grommet into here and then soldered directly onto the board. It's no big deal, you know, there's not many conductors here. There's TX, RX, ground, plus 24 volt and an E-stop line. It's the usual trick with this stuff, so just to help things along I'm going to use some 60/40 tin lead solder. Just let that cool. I'll tell you what, that joint looks a bit sort of how you doing. I mean, I'm sure it was fine, but just for something that costs as much as this does, it's a little bit disappointing, isn't it? If you buy something for £3.99, including delivery from China, you expect the odd sort of messy, dirty joint, but for the prices that these people are charging, really, it ought to be better. Okay, so I think the next thing I'll just clean all this solder off here. Just re-tin it with some 60/40, and then we'll get this we'll get this plug socket arrangement out of here. So what I'm going to use is just one of these cheap, nasty eBay solder suckers. They are incredibly poor. I need to get myself a decent solder removal system, really, and a little bit of solder braid. What I use is, I just use the solder sucker to get rid of the bulk of it, so that I'm not wasting so much solder braid. To sort of really clean the job up, it's the solder braid that does the hard work. I'm just using this so that the solder braid doesn't have quite so much to soak up. So I don't know if you can see what's happening here. When I got started with this stuff originally, I was really frustrated because a lot of people had whipped up a lot of hype about this stuff like it was magic. And it sounded great. but I couldn't get it to work. And the reason I couldn't get it to work was because the soldering iron I had at the time was a little 18-watt soldering pencil. Great for soldering, no problem, but for doing work like this, where you need to heat up the solder braid and you need to heat up the joint and the solder, and it all needs to be hotter than the melting temperature of the solder. So the little 18-watt soldering pencil didn't really have the power to do that. So it didn't work. And I don't know if you can see sort of the yellow deposits coming out of it. That's the flux. It's got a heat activated flux in there that helps the solder flow into the braid. Okay, so I just let it dither there on the pad for a second, just let the heat get into it. And then I just pull on the braid and follow it with the soldering iron. Okay, and all the solder gets sucked up into the braid, and you just chop that end off, leaving you with a fresh end to use. Okay, so what I do is I go back in there with a bit of acetone. I've got some in one of these little squidgy bottles, I don't know what to call them, with a pipette. Put a bit there on the bench, soak it up with a cotton wool board. Oh, that, by the way, I've started buying these from eBay from China, and you know why? I used to buy branded Johnson's cotton wool buds, and they've changed the stem from being plastic to a kind of paper, and it'll be for the purposes of being green and EU compliant and all this sort of stuff. Unfortunately, they fall apart when you're doing work like this. So that's it, I've started buying these from China now. So yeah, these ones are wood in the middle, and they've been fine so far. You can see all the solder flux that's come out of the end there. Okay, so these joints are now nice and clean. So I'll just re-tin each one. The flux that's on there, I'm going to leave that on there until the job's finished. When that flux is all burnt away, that flux that's there is now partially used. If I was heating this up and heating it up and heating it up and reworking the joint, all the flux would be spent, it would be dead flux, and what you'd find is the solder would sort of string and it would sit on the soldering iron, and it wouldn't flow and make a nice smooth joint, a nice shiny joint like you see there. So whenever that happens, you can add a little bit of extra flux. I've got some of this stuff. I bought it on eBay. There's various different fluxes. What I've done is these tubs, they're like 8 or 9, 10 quid each, depends where you get them from, for a little tub of this stuff. I don't know how much it is. What quantity of liquid? 50 millilitres. Yeah. What I keep doing is knocking them over on the bench, you know, and watching 5 quid's worth of liquid just flood out all over my bench, and there's not a lot I can do about it. So what I've done is I've sat it down into a little plastic tub and then filled the rest with fiberglass resin, and it makes for a nice heavy base so it doesn't knock over quite so easily. Well, whoever came in here before me, and I assume that's the manufacturer, they really had some fun. If you look on the edge of each sort of flat, there's a bump, and what that is where somebody's been in there with an adjustable spanner that's too loose, or a fixed spanner that's too loose, the wrong size, and it's just sort of pinged over the edges of the bolt head, if you like. It's not exactly clever, is it? Okay, so I'm going to use a 17mm socket and my big-ish breaker bar. So I've stripped down the grommet here. Okay, so we'll use the old Scandinavian Widowmaker. Okay, can you see how much that, that is not ready to use? That's going to peen over the edges like the last person did. So now there is absolutely no play on it. If I move the spanner, it moves the nut. Well, my suspicion is that isn't going anywhere. Right, so we've got the original part of the cable loom off the remote, grommet fitted. We just need to adapt the cable now, so we need to make sure that we get the right end of the cable, otherwise that would be fairly catastrophic. So this is the end that went onto the remote here, so get that end out of the way. I've left enough of this now that in a hurry, in a pinch, all of this lot could be used to repair another remote or something else quite quickly. There's enough slack on the end of here that it could be adjusted, messed around with. So I think the way that I'll have this is, with this coming out through here, it solders to somewhere here on the board, so we want some sort of slack inside. So I think I'm going to strip it off back to about here. Okay, so that's actually pretty cool, isn't it? The whole thing is braided, which will fold back no problem. And then we've got a separate conductor, which is obviously bonded to all of this. And then a foil layer for even higher frequency stuff, presumably. Just get rid of the foil. We've got the rope, that can come off. And then the individual conductors. Okay, so the conductors that we need for this are white, TX, red is RX, blue, which is ground, of course, brown 24 volts, and black is the E-stop. The grey isn't used, so we can vanish the grey. the braid can also come off the end here. This conductor here, which is bonded to the braid, the idea is that the cable, the braid around the cable is actually bonded to the case of the remote. This grommet is sort of partially insulated throughout, so this grommet isn't going to do the same job as the last grommet. I think they've done it inside the moulded plastic plug is the way that they've done it, but I'd have to totally rip it apart to see. But basically inside the plastic plug, I've checked it for continuity off camera, and the braid does bond through onto this grommet, this socket assembly, and that is obviously connected to the case. So we'll have to do something a bit imaginative with this in a minute. Anyway, so I'll just prep the end of each one of these. Just twisting the ends up to stop the individual wires from flying around all over the place. Okay, so for bonding this to the inside of the case, there's nothing really in here that we can sort of access. There's no screws, and I don't want to drill any holes. However, what we do have is on the back of the board there's these soldered in threaded posts, and they interact with the screws that you put into the back of the case. So basically these pegs, these threaded pegs, are sort of going to be bonded to the case. So if we do something, if we solder something like that onto there, this sort of shield braid conductor can be bonded onto there, just sort of crimped on. We'll put some heat shrink wrap on it to stop it from shorting anything out. Right, so I've had to be fairly careful about the order that everything goes in. So I've put some clear heat shrink around the earth bond conductor here. We've got the original plastic sort of insert from the grommet. After that there's a little rubber insert that goes into here. Then we've got the screw cap that sort of tightens everything down. That's what pushes all these legs together and holds the cable steady. And then after that, this heat shrink wrap is going to go over the top of this cap. So it all has to go in, obviously, in that order. Okay, so here I want there to be a little bit of grey showing, so that it's, you know, I can be certain that the grommet is grabbing a hold of the insulation and not the conductors. I see that quite a lot, where people have got the cable where the grommet is actually grabbing a hold of the conductors. It shouldn't be. It should be grabbing the outer insulation. Okay, and that now is absolutely solid and it's not going anywhere. What I've got is one of these. It's actually for putting cable marking onto the outsides of cable, but it's useful for this kind of a job. So just stretch the shrink wrap here, and then hit it with a hot air gun. Okay, and then this bit on the earth conductor. And then finally, this will just dress the end of that up. I've got the insulation off the outside of this ring terminal, and the next thing we're just going to solder that onto this tab here, and that'll give us something to put the earth conductor onto. So what they've done, the way that they've designed this, is that the ground plane of the board, there's well, it's not really a ground plane, I don't believe. I don't think that's actually copper under the board. They've just done a sort of really huge via, like a plated through hole, I guess, and then they solder these pegs into the through holes. Now that's all fine and dandy, but on the other side you've got a self-adhesive membrane keypad, and it's only sort of like a plastic, so what's going to happen is that's going to end up melting. So I've got a bit of wet sponge here that I'm going to put underneath the keypad, and that'll just keep the heat moving on its way. Okay, so there's some solder on that. I just want to strip the heat out as quickly as possible. Keep moving the sponge around. So I just want to raise that off the board ever so slightly here. So it just boiled the water. That was 100 degrees centigrade we'd hit. Okay. And because there's a fair bit of thermal mass there, I should be able to solder into that hole with no dramas, like that. Okay, then a bit more shrink wrap on there. And that's that. So now obviously when we put the screws through the bottom there, these touch onto here and they're also sort of screwed home, so that'll provide quite a decent earth bond. Okay, so that's the black for E-stop, and then brown for the plus 24. Okay, so now I'll go back in there with some acetone on a cotton wool bud. There's actually no reason for me to do this as such, because this is a sort of no clean flux. There are some types of flux that have a kind of etching quality to them, and they will eat away at traces. This isn't one of those types of fluxes, but there we go, nice clean joints. So one of the things here is that I've left enough slack in the cable that you can remove the front panel and lay it over on the desk. Otherwise it could be awkward to get into the back here if you needed to for some reason. So anyway, and that's it. We just put the screws in the back and this should hopefully fire up. Okay, so now rather than that cable socket arrangement that was there before, we've now got this grommet. It's not going to pull off, and if the whole thing is dropped, there's some sort of strain relief there. Also there's a sort of quick and easy solution, like if the cable did start getting damaged down here, so what, cut it off and repeat the process. No particularly big deal. Just get some sort of 6-core shielded cable to extend it if required, and that's that really.